simple harmonic motion. Basically, that's what it is. It's not called simple harmonic motion because it's simple, although it is. It's the actual motion itself that's very simple. It just goes backwards and forwards between 2 points, and it's defined this way. Its acceleration at any instant will be directly proportional to its distance from some fixed point. So basically we're saying that. Right? Acceleration is proportional to the displacement. Well, that therefore means it's equal to some constant times the displacement. But in order for that to work, that constant needs to be negative. So to ensure it's negative, we make it minus n squared. Then we've got to get a negative number. So that's it. That's all we know. That little differential equation. So let's play with it. V to v dx therefore is minus n squared x. Separate my variables. Now, I need some initial conditions. So what do I know? I know that when it gets to its furthest point, it stops. I'm just going to call that A. So when it gets to A, the velocity is 0. Let's find the relationship between v and x. So we integrate. V squared ends up being n squared, A squared minus x squared, which means v is plus or minus n root A squared minus x squared. Now that tells me something. It confirms what I was just talking about, because v squared has to be positive. Therefore, a squared minus x squared is positive. The solution to which is x is in between minus a and a. So there it is. It's going backwards and forwards between those 2 points. That's all it does. Let's keep going. We're going to find the displacement equation. dx to t is minus n. Now, why did I choose minus? I had choice plus or minus. I want to satisfy the initial conditions, but in this case, the initial conditions I chose, the velocity was 0. So I could have picked either. It didn't matter. But I did it for a reason, and that's the reason. I chose negative because I was out at the amplitude. See, I know it's going to end up being a trig curve. So I want to get the one that matches my motion. Which motion do we start? Which trig curve do we start at the amplitude? That's the cosine curve. So I want to end up with an inverse cosine function when I integrate. Well, inverse cosine, if you remember the standard integral, is minus. That's why I picked minus. If my initial condition was I was at the center, x equals 0, then I'd choose positive, and then it would turn into an inverse sine function. Just making the maths easier for myself. So the t dx, there it is, minus 1 on n root a squared minus x squared. So maybe now you recognise it as, oh yeah, that's going to be inverse cos. Separate the variables, sub in, and there we have it. Well, sort of have it. It's an expression for t in terms of x, but we want an expression for x in terms of t. Okay. Multiply out, play around with it, and we just got a basic cosine function. And we got that because of our choice right back there of getting the negative. If I'd gone with positive, I would have ended up with a sine. There'd be some shift happening to make it all work. It's just messier. Okay, so in general, that's what we know. From there, we can create this, and that tells us about the path of the particle. But then we also know it'll end up being a trig function. Might be sine, might be cos, depending on how we chose our pronumerals. The particle has period. It still has a thing called period. It's a trig curve. But what does the period mean now? Period means how long does it take for one complete oscillation? So go backwards and forward, and you're back. The other thing we're interested in is frequency, and that's just the reciprocal of the period. And that's how many oscillations you will have per time period. Yeah, it's usually seconds, but whatever the time period is we're using. Let's look at some questions. So they've given us the displacement equation this time. And one of the things they love doing is say, well, show it's moving in simple harmonic motion. So I need to show it satisfies that differential equation. Just a little bit of differentiating. So x is 4 sine 3t, so velocity 12 cos 3t, acceleration minus 36 sine 3t. Oh, look at that. That's equal to minus 9x. So it is in that form of minus n squared x. So yep, that is simple harmonic motion. Actually, it probably would have even been better if I wrote because acceleration equals minus n squared x. It actually explains why I can make that statement. It said find the period, remember, minus n squared x. So n in this case is 3. Period was 2 pi on n. So 2 pi on 3. Units I'm using here, although it didn't say in the question, I'm just assuming it's seconds for the time units. Find the interval the particle moves. Now here, I don't need that other equation. It's a trig curve. So x, what does it move between? Well, amplitude's 4. So it just goes in between minus 4 and 4. What's the maximum speed? Again, it's a trig curve. What's the maximum of 12 cos 3t? It's 12. Bang. I don't have to waste time with calculus with this one if we're starting with the displacement equation. I just use what I know about trig functions to answer. Well, let's see one that goes back the other way. So acceleration is minus 4x. Again, let's find the interval. All right, v to v dx. Separate the variables. Sub in the initial conditions. We've got, there it is, x equals 3, v equals 6. Integrate, and there we have our v squared formula. Well, we know v squared has to be greater than or equal to 0, therefore x is in between minus 3 root 2 plus 3 root 2. What else did they want? The greatest acceleration. Okay, well, I now know the path of the particle, and acceleration is a constant times displacement. So whenever displacement is a maximum, acceleration's got to be a maximum. So I just sub in the amplitude here, 3 root 2, into the acceleration equation, and that will tell me the biggest it is. So minus 12 root 2, well, it could just as easily been positive 12 root 2 if I chose the other end. But what we're interested in is 12 root 2, the size of it. So the greatest acceleration is 12 root 2 centimetres per second squared for acceleration. Let's have a look at some HSC ones. So, quite an old one to start off with, 10 years now. Oh, look at this. It's got 2 trigs in there. 6 cos 2t and 8 sin 2t. Proved that the particle is moving in simple harmonic motion. Gave us a hint. We're going to show it's in that form there. So there's some sort of shift happening here. The centre mustn't be the origin, I guess. They've shifted the curve a bit. 6 cos 2t plus 8 sin 2t. I notice the angles are the same. So let's turn it into one trig function. Sine or cos? What do we want? I went for sine. Sine, cos, cos, sine. If it's a sine, it's the sine. So we end up with 10 sine 2t plus alpha. I didn't bother writing down inverse 10 and 3/4, but I mean, that's what alpha is. Obviously, I need to note it somewhere. So x equals 5 plus 10 sine 2t plus alpha. We want to show accelerations in that form, so let's differentiate twice. Can I manipulate now? And yeah, I'll add 5 and subtract 5, and I've got minus 4, x minus 5. That's in the form that they've said. So, yep, we got it. It's in that form. Look, I know I've just said minus n squared x here, when really it's n squared x minus c. That's fine. I mean, we're not worried about the shift. We're basically saying it satisfies the simple harmonic motion model. So that's cool. We can do that. When is the displacement of the particle 0 for the first time? Okay, so in other words, when is that equal to 0? We're just solving a trig equation. Okay, sine 2t plus alpha. I got a couple of possibilities there. Remember, alpha is that inverse tan of whatever it was. Subbing in, we get 1.5. So after 1.5 seconds. Now keep in mind, there it is. There's the path of our particle. But always remember these key points. At the amplitude, velocity will be 0. That's where we stop. But acceleration will be at a maximum, because when displacement's a maximum, acceleration's got to be a maximum. So out there. In the centre, velocity will now be a maximum, but acceleration will be 0. All right. Let's have a look at the first time it was in the new course and it became extension 2 rather than extension 1, where it used to be. So 2020, particle undergoing simple harmonic motion, they're giving us a period. Oh, the centre is not at 0, it's at root 3. Maximum displacement of 2 root 3. Simply find an equation for the displacement. Well, I drew myself a little picture to try and get my head around what's happening here. The centre is root 3, not at 0. 0's over there somewhere. But the amplitude, well, how did I work that out? Well, they've said maximum displacement of 2 root 3 from the central point. So I know it goes out to 3 root 3 and back to minus root 3. So I know that. I know the equation must be in this form. Right? It's starting at the amplitude, so I want it to be a cosine curve. Make life easy for myself. But there's some shift happening, so I've added a constant. I just got to work out what A, N and T are. Well, they told me the period is pi on 3. So 2 pi on n is pi on 3, I've got n. It's equal to 6. C is the shift. We've moved it root 3. There's my shift. So I've got C. The other thing we need to know is A, which is the amplitude, and that's 2 root 3. So there's my equation. I've got a possible equation for this problem. 2021, so last year's, we got an acceleration. Initially the object's 5.5 metres to the right of the origin, moving towards the origin, has a speed of 8 when it passes through the origin. Notice they've used the word speed there, not velocity. I guess what they're saying is sometimes it'll be positive, sometimes it'll be negative. Basically saying, what's the path of the particle? Okay, there's acceleration. V to V dx. Separate the variables. Sub in what they've told me. I'm going from x equals 0 when velocity is 8. Integrate. Sub in. I've got my quadratic. That's got to be greater than or equal to 0. You see, same sorts of questions all the time. X minus 3. There you go. I'm going in between minus 2 and 8. There's the path of my particle. Find the first value of t for when they're, well, basically when is it at the origin. Make use of your reference sheet. On the reference sheet, they said acceleration is equal to minus n squared x minus c. So for our problem, n is 2, c is 3. But they also told us it's this, and we've created ours as well. Now, a is equal to 5. We worked that one out. There's my equation. And now we want to know when t equals 0. So when t equals 0, x is 11 on 2. So 11 on 2 is 5 cos alpha plus 3. Alpha is pi on 3, solving that. When x equals 0, again, another trig equation. So the first bit was to work out what alpha is, because we didn't have that piece of information in our problem yet. We had the other stuff, but we still needed to find alpha. So I subbed in that data to get alpha. Now we can work out when it's at the origin. And there it is, t equals 0.58. So a couple of exercises there. The first exercise, they start with the trig, and then usually ask you to prove it's simple harmonic motion. The second is one that goes back the other way. Starts with acceleration, and you're going that way.